Hey, good morning, good afternoon, or good evening, depending on what time you're watching this. I'm Dr. Benson, and today we're going to be learning about weather fronts. This is where weather gets a little bit more complicated. So let's start by seeing what we remember from last time. We talked about air masses and how pressure affects the weather. Is a high pressure air mass more clear and sunny, or more cloudy and rainy, and why? Yeah, and if you've never seen one of these before, this is called a weather stone or a weather rock. It helps you tell the weather. If the stone is wet, that means it's raining. If the stone is not wet, that means it's not raining. If the stone casts a shadow, that means it must be sunny outside. If there's white stuff on top of the rock, it's snowing. If you try to look at the stone and can't see it, it might be foggy. If it's swinging back and forth, it might be windy. And if it's completely gone, then there must have been a tornado. Because I feel like this is the world we live in. Some people don't know how to tell what the weather is without looking at a phone or an app or something to tell them. So last time we talked about air masses, and we said the pressure of the air mass affects the weather inside that air mass. Cold air masses have high pressure. High pressure air sinks. When the air sinks, it comes closer to the ground. It warms up a little bit, and that makes the clouds disappear. That makes the relative humidity decrease, and that allows the sky to be clearer and sunnier, albeit colder. The low pressure air mass is the warmer air. Warm air rises, and when it rises, it makes rain clouds. Well, this is what happens in the middle of an air mass. The big weather events come from where the air masses meet, because that's where the weather is actually changing. At the edges, at the borders, at the boundaries of the air masses, that's where we have the kind of competition between these two different air masses. And so we have some extreme weather events that can happen. If we're talking about a low pressure air mass, a warmer air mass, we call the leading edge of it a warm front. So as it moves, it pushes through the other air mass, which must be colder, and it creates this leading edge, and we symbolize that with a red line, red for warm, and these semicircles to show us the direction of movement. And so this is for a low pressure air mass that moves. For a high pressure air mass that moves, it's cold air. We know that, so we call it a cold front. And here we can see the temperatures that are on either side of that front, and you do see those temperatures change as the front passes through. It's blue because it's cold, and it's got these triangles instead of semicircles. The triangles showing you the direction of the movement. Now, if you look online, there's also stationary fronts and occluded fronts and probably some others. Don't worry about those. They're complicated. Just this is enough for now. Just this is enough for your test. So as long as we understand these principles about weather fronts, you're golden. So this is how we show the front of an air mass as it moves, and this is where the weather is happening. So let's start with the warm fronts. We see our red line with the semicircles on the ground. The warm air is rising. The warm air extends higher into the atmosphere than the cold air does because the cold air is sinking. So as the warm air pushes into the cold air, it actually pushes over it. It pushes from the top. So as it does, it creates kind of a wedge shape here. It creates kind of like a triangle shape here. The clouds essentially lay down on top of the cold air because it's this cold air that's causing the moisture here to condense. And so what we have is a long sheet of clouds, a long layer of clouds, and we call those stratus clouds. Stratus means layer, and this is just a big layer of clouds. And what this warm front brings is rain. A light rain, kind of like a drizzle, but it usually lasts for a few hours or a few days. Because it's so spread out. It takes a while for it to blow over. These fronts also move kind of slowly too, because if you can imagine this is low pressure moving into high pressure, that's not the way wind is supposed to move, right? It's not so much the wind moving at this point, it's actually more about the heat energy moving, but don't worry about it. They move slowly, and when they do, they create this wedge as they kind of lay down. The warm air lays down on top of the cold air. Cold fronts are a little more violent. Cold air sinks, so it comes in low. It comes and pushes under the warm air. It's kind of like being hit by a car, I imagine. If you get hit by a car, you kind of roll up on top of the hood. It happens very quickly, and that's exactly what's happening here. Very quickly, this warm air is being forced to rise. Not just rising like it naturally would, it's being forced to rise very, very quickly as this cold front moves in, and that creates severe thunderstorms along the boundary. Right over the boundary, sometimes a little ahead of it, sometimes a little behind it, but usually right at the front, we see thunderstorms. They create these cumulonimbus clouds. Let me find you an internet picture of a cumulonimbus cloud. Alright, so here we're looking at some cumulonimbus clouds. Cumulus are the ones that are kind of fluffy and white. They look like puffballs. They're really beautiful, I think. The nimbus part is about them being dark and gray and full of rain. In this case, we don't have the little fluffy clouds. We have huge clouds. They stretch miles up into the air. And then they kind of flatten out, kind of this anvil shape, they call it. These anvil-shaped clouds are the severe thunderstorm clouds. And this is caused by all of that warm air rising very suddenly at the beginning of a cold front. And that's what we see back here. We have the towering cumulonimbus clouds with their kind of anvil-shaped top. Imagine how dense this cloud is. We said that the cloud itself is made of microscopic droplets, and the droplets have to get heavy enough before they fall as precipitation. Here, they're falling through a lot of other condensation on their way down. So these raindrops get bigger and bigger, heavier and heavier, and that's why we have this heavy rain with flash floods. It also creates electrical events like lightning and thunder. And if we have more time, we might talk about that in a day or two. So right here at the cold front, we have terrible thunderstorms. Compare that with the warm front again. We have light rain, and this is ahead of the front. The clouds are all ahead of the actual front. We're out here on the ground. We're waiting for the actual front to meet us. We see it coming days in advance because we see these clouds come on days in advance. But we have to wait until it actually warms up for us. Here, we don't get a lot of advance notice. We have to track these through meteorologists, through weather stations, because otherwise these would come up on us and cause severe damage. So weathermen, meteorologists try to track the movement of these fronts so that we know when and where the severe weather will occur. Here's some more diagrams trying to explain it to you, and it's tricky because what you really need to see is animations, and I'm going to show you some animations in a second. What I really need you to know the difference, though, is just the types of weather that are created at each front and kind of the shape these fronts take. So here, I see warm air moving. That must mean it's a warm front. That must mean this is low-pressure warm air, like a tropical air mass. It's blowing still mostly over. It's kind of laying over the cold air. Here's the cold air moving. That's how we know it's a cold front, is the cold air moving. It does not have that nice flat shape like it did over here. Now the cold air is moving kind of like a wall. Almost like a wall, kind of like the front of a car. And so when it hits that warm air, it pushes that warm air up and over to create the severe thunderstorms. And here we can see another picture at the bottom. Same thing. This is our warm front. We see the warm front symbol here. Usually you would see it drawn on the ground, but that's okay. This is just an artist interpretation. It's telling us that far ahead of the front, we start to see high clouds called cirrus clouds. But then the clouds slowly start to settle, and they become more and more stratus, nimbostratus, by the time they turn dark and start raining. So light rain, steady rain over a period of time. This cold front, on the other hand, when it hits us, it creates heavy rain, thunderstorms, these giant cumulonimbus clouds. And then as the front passes, we might have a few light showers still. But once we're inside the air pressure air mass, the weather becomes great, like we talked about. And that's because as the clouds are allowed to sink down, they evaporate. The relative humidity decreases, so it allows the moisture to evaporate better. Here we see some more pictures of the same thing. When we have the warm air moving in, that's the warm front, and it lays down on top of the cold air at this angle. It lays down on top, so it creates these stratus clouds, these layers of clouds. versus the cold air comes in like a train, like a bulldozer, and it hits the warm air and makes that warm air rise suddenly to create our thunderstorm clouds. Here we see the same thing, cold front, warm front. Here it actually tells us the shape is how we can tell the difference, right? So they call this a bulldozer shape with the cold front, and they call this more of a ramp. Warm air comes in kind of like a ramp. The cloud types like we talked about, the cumulus, cumulonimbus clouds, the very tall, towering clouds found in front of, or along cold fronts, I should say. Here, in front of the front, in front of where the warm air touches the ground, is where we have these stratus layers of clouds, stratus clouds spread across the sky, bringing us the light rain. And then the third thing it says is precipitation, because here it's very intense, heavy rain. Here it's more steady, more like a drizzle where it's just wet for a day or two. And here we see a picture of, surprise, the same thing. Here we have the red line on the ground, marking where that front actually is on the surface, and we see that the clouds are in front of the front. The clouds precede the front. We see the stratus clouds moving on, and then we hit the warm air. And within the warm air, we're still having these rain clouds, because warm air makes rain clouds. The air here is continuing to rise, and when it does, it condensates and precipitates. So here we have light rain ahead of the front, usually light rain in the middle of the air mass. Here, we have tremendous thunderstorms at about the front, sometimes a little ahead, sometimes a little behind, these towering cumulonimbus clouds. But then once we're in the middle of the air mass, it clears up. It dries out, because the high pressure, again, is bringing the clouds down so that they evaporate. They don't have to condensate because of the high pressure. They bring the clouds down so they dissipate. So today I've got a couple of YouTube videos for you. And we're going to do all these together now. Try to do it in one Edpuzzle instead of two separate Edpuzzles. Let me know what you think about that. The first three are by the Meteorological Office of the UK. We've already seen some of their videos because they put a lot of good weather videos on YouTube. This middle one, fourth one I guess, is by a meteorologist at the Weather Channel. And these last two, it's showing you a computer simulation that another teacher is just showing us the simulation. And I wish we had a simulation like this, but unfortunately we don't. So we're going to start at the top here and work our way down on the YouTube videos. Alright, here we are, the Meteorological Office of the UK. The Met Office, they call it. Let's skip ahead a little bit.
You may have heard weather forecasters on television talking about a warm front or a cold front approaching, bringing with it a change in the weather. But what are they going on about? What is a weather front, and how does it affect our weather? A weather front is the boundary between two bodies of air with different temperature and humidity. These differences depend on where the air has come from on the globe. For example, air sitting over tropical oceans becomes very hot and humid, while in contrast, air over the Arctic becomes very cold and dry. That's logical enough, but what happens somewhere like Britain, where our climate is neither tropically warm and humid, nor polar cold and dry? Over the Atlantic, these warm and cold air masses often meet. Just like oil and water, they don't mix easily and can become unstable as a result, giving us an active area of weather in which fronts form. When air masses first collide, it's impossible to know if we're looking at a warm or a cold front. It's only when one air mass dominates that we can distinguish between the two. If the warm air is stronger than the cold air, then this is called a warm front. You may have seen this on TV as a line with red semicircles along it. The semicircles point towards the cold air and the direction in which the front is moving. If the cold air has the upper hand, then it's a cold front, which is shown by a line with blue triangles along it. The blue triangles point towards the warm air and again in the direction of movement. But what is happening when two opposing air masses meet, and what kind of weather does each front produce? On a fine day, if you see a layer of very high cloud beginning to spread across the sky, usually from the southwest in Britain, it may mean that a warm front is approaching. Warm air is less dense than cold air, so it tends to ride over the top of the cool air it's replacing. This creates a vertical slope to the frontal system, with the front first being seen high in the atmosphere, miles ahead of the front at ground level. As the warm, moist air is forced to rise, it cools and water vapour condenses into water droplets or ice crystals. These form clouds that you see approaching, first as high cirrus clouds and then as thicker clouds. It's these interactions which form clouds. If you're measuring the air pressure as the front approaching, you'd see that it's falling. This is because the column of dense cold air above you is gradually being replaced with more and more warm and less dense air as the front moves closer. Layers of cloud also deepen and rain begins to fall. A warm front usually produces quite a long period of light and drizzly rain, with a shorter spell of heavier rain at the beginning of the front. The rain or drizzle will eventually die out once the front has moved through, but it will often stay pretty cloudy. You might think that a warm front would mean nice warm weather, but unfortunately that's not always the case. All that rain and loss of sunshine can mean that temperatures are actually lower than they were before the front arrived. So why is it called a warm front? Well, the cold, dry air mass has been replaced by a warm, humid air mass. It just doesn't feel much warmer. But what about cold fronts? Warm fronts are easy to spot because you see the leading edge of high cloud approaching on the horizon across clear skies. However, warm fronts leave clouds behind, and the following cold front sneaks in under the cover of the clouds. This makes them hard to spot just using your eyes, as it's difficult to see any changes that might be on the way. But remember that the pressure falls with a warm front because the air is less dense. Well, the opposite is true with a cold front. A cold front is a bit like a wedge. The air is colder and more dense than the warm air, and it scoops it up, causing the pressure to rise. And we can spot that using a barometer. So what kind of weather does a cold front bring? Deep cloud layers form as the warm, moist air is forced to rise and cool. These cloud layers produce lots of rain, often in bands, and these bands tend to be quite narrow, with heavy rain in them, sometimes with even hail and thunder. Once the front passes, there's often a dramatic clearance with blue skies, bright sunshine, as the cold air descends as the front passes. Temperatures fall at first, but they may rise again when the sunshine appears. However, this sunny weather doesn't always last for very long, because if the cold air is warmed, it will rise, or convect as weathermen say, and produce showery rain clouds, such as cumulus or cumulonimbus. As we've seen, weather fronts can be complicated things and bring with them some very varied weather, which is one of the reasons we have such an interesting time of it here in this country. We've looked at how warm and cold fronts are formed and what sort of weather they bring. But if you want to learn anything more about weather fronts or anything to do with weather and climate, visit the Met Office website.
Yeah, and he's absolutely right. They have a lot of excellent online resources. So this was a really good video. It was a little long, but he explains that where the boundary is, it's not really a front until they start moving. Where the warm air moves, that's a warm front. Where the cold air moves, it's a cold front. He said that at the warm front, where the warm air is moving, it starts at the top, and so we see the formation of clouds ahead of the front. In the middle of the warm front, he said, it stays cloudy, it stays rainy, because this is the low pressure area. And he also said that we can detect this with a barometer. We see the warm front coming, the warm front, the low pressure air, because the barometric pressure, the air pressure itself, drops. You can see that, you can feel that coming. On the other hand, this hits pretty suddenly, so we don't have a lot of anticipation of it, but these cold fronts create the most severe thunderstorms. Once the storms are out of the way, though, we tend to have the good, sunny, clear weather. And this is why in Georgia, in the summertime, we don't see this kind of cold being sunny. We tend to think of clouds as being cool, and the sun as being hot. But that's just in Georgia because we get such intense sunlight, because we're so close to the equator.
Remember.
And this is another meteorologist. Why do I have trouble saying that word? Another meteorologist from the Meteorological Office, the Met Office. They're speaking English. I love the English accent. Some of y'all might not. This one doesn't have closed captions, though. So hopefully we speak English. Let's see what he's going to say.
Airport. There is a weather front just gradually pushing its way northwards through Thursday. It's a warm front bringing milder air across the south.
And I mentioned this, it might have been online during the Zoom conference, but it's kind of like the air masses are battling, and the front lines where all the action is, that's the front. We measure these air masses based on their temperature and their humidity. And depending on which one is taking over, it's a dramatic change in weather as the temperature changes, as the moisture changes. The bigger the difference in temperature, the bigger the difference in pressure, the more severe. We said not to worry about occluded fronts. Warm air rises. As it rises, it cools. It reaches its dew point. It condensates to form clouds. And we can see these hundreds of kilometers ahead of the front. But you can see this time lapse over the course of the day. It's like a low sheet of clouds. Just clouds everywhere. And even once the front passes, it stays a little cloudy because you're in the middle of a low pressure area. So remember that cold air sinks. So the cold air, when it invades, it does so from the bottom. The warm air is not allowed to rise by itself gradually. It's forced to rise all at once, creating these severe thunderstorms in a region. But when it passes, the sky gets very clear, very blue. Skip this part about occluded fronts. Occluded fronts are when they catch up to each other. You can also have a stationary front where they're just kind of stalled, not moving in either direction. We're just worried about the warm front and cold front, though. So here's another video explaining to us these fronts, again by the Met Office. Oh, this is the experiment guy. So
in this film,
he's going to
we'll
show
see a
us, and this is something we would be
demonstration
doing in
that
a
will
lab
help
at
to show what
school.
happens
We'd be doing
when
this in
warm
the fish
air
tanks.
meets cold air in the Earth's atmosphere. We'll use water to simulate the behaviour of the air. I put tap water into this tank. Now I'll add this plastic gate in the middle to divide the tank into two halves.
So he's got a tank full of water and he split it in
Next, I'm going
half.
to add some warm water to this side and some cold to this side. I've also dissolved some instant coffee granules in the cold water so that we can see where it goes.
He's pouring hot water in one, cold water in the other. And he's using coffee instead of dye.
Now I'll
because
pull
he's
out the
British-
gate and we'll see
British
what
blue.
happens.
I love British people, actually. This cold, it
They
comes in
don't
from the
immediately
bottom
mix
because the cold
together.
is sinking.
Instead,
this warm
the
that's moving
lighter
over, it's
warm
warming
water
over from the top
rises and
because it
overruns
rises.
the cold. The more dense, cooler water sinks and undercuts the warm water. Notice that the movement is one way at the top and the other way at the bottom. Something similar happens to the air in the Earth's atmosphere at a front, a boundary between warm and cold air. This is only part of the story, though. We'll see in the film entitled The Thermal Wind that this overrunning and undercutting is modified in the real atmosphere by the Earth's rotation.
Yeah, so this is a great demonstration of, you can see how the air is actually moving. And of course, the air outside in the atmosphere is invisible. We don't actually see this taking place. We
They
have
don't
to measure it
immediately mix
using
together.
scientific instruments.
Instead, the lighter warm water rises and overruns the cold.
the warm water
The more dense, cooler
invades from the
water
top,
sinks
the
and
cold
undercuts
water
the warm water.
invades from the bottom. So right here, this leading edge would be the cold front, and then this would also be the warm front, because this is where the warm is touching the ground. So in this case, they're kind of going in both directions at the same time. In the atmosphere, though, usually it's one air mass invading the other, kind of from behind. They're not going in the opposing directions necessarily. So here's a similar demonstration, but it's from a guy on the Weather Channel. And so it's a little prettier, I guess.
Here at the Weather Channel, we talk about fronts all the time. Cold fronts bringing in cold air, warm fronts bringing in warm air. But these are 3D invisible features in the atmosphere. They're really hard to get your head around. So what are they really? Well, a cold front is actually the border of two different air masses. When it moves on in, the cold air goes underneath the warm air. It's heavier, it's more dense, so it sinks. Warm air, on the other hand, is lighter, and so it rises up above. Still, hard to see that in the clear sky and the clear air, so we have a little bit of a substitution. See, air is a fluid just like water, and we get to use food coloring in water to help make this a little bit more visible. In this glass, we've got cold water, conveniently colored blue. In this glass, warm water, colored red. Now, I'm not gonna lie, this is a bit of a messy situation, so if you're doing this at home, it helps to have a towel nearby. So cover up the warm red water, flip it upside down, and put it directly onto the cold glass. You separate the two, and well, basically we've created a front. We now have the separation of the warm water on top and the cold water on the bottom. I know it's not very impressive yet because that's how it started, right? It becomes more impressive when we move it onto its side. Just like when a cold front comes in, the hot water stays on the top of the atmosphere, cold water down at the bottom, and the purple that you see is the actual front separating the two different air masses. So convenient when it's in water, not so convenient in the air, but it still works exactly the same way.
Yeah, so he makes a great point. We can't really see this in the atmosphere. I appreciate that he used food coloring instead of just coffee grounds. It's a little prettier. But we can see that the red is invading from the top because it's less dense. The blue is moving over from the bottom because it's more dense. So the high pressure air moves in from the bottom, the low pressure air moves in from the top. Now these last two videos are the simulations I mentioned, and they're really good. So let's see how this works. This is the warm front first. The warm air is essentially squeezing the cool air, kind of like you would a tube of toothpaste. The warm air is higher in the sky. The warm air is invading from the top. And the moisture in that warm air is condensating as it touches, as it interferes with the cool air. So we see those layers of stratus clouds developing, creating that hours or days of light rain. And then this is our cold front. Here the cold air is moving in low. It's coming in from the bottom. So we see a much more rapid rising of the warm air. And we see bigger clouds. We see more severe rain. It's not as slow, not as gentle as the warm front. This cold air hits a lot harder. It is more dense. So far we've learned about the weather inside the cold front, inside the cold air mass inside of the high pressure cold air mass. So that inside it's very sunny, but at the front it's very stormy. The low pressure air, the warmer air mass, the tropical air masses, They have a more extended range of rain showers that are pretty constant. And inside the air mass is also with a lot of rain and showers. So these are the major things that we track on a weather map. And we'll learn more about weather maps tomorrow. So ticket out the door. Which type of front that we learned about, warm or cold, causes the most severe thunderstorms? And I want you to explain why. And if you made a good explanation, that's literally the standard. That you can explain the relationship between these pressures and masses and fronts and storms. So it starts off with the cold air, high pressure air inside a cold air mass. As it moves, it creates that cold front. Well, as the cold front pushes under the warm air, it forces that warm air up, and that's what creates these towering cumulonimbus clouds that create thunderstorms. The standard also mentions weather events like tornadoes. We'll talk more about tornadoes Thursday or Friday, because they're pretty interesting too. And then one last thing before we leave. Mistakes are proof that you're trying. Mistakes aren't something to be ashamed of. Mistakes are proof that you tried. So thank you for joining me here today. I will see you tomorrow.